Section 9.4 is an introduction to vectors. I would pause the video and write down these notes. So a vector is a quantity that has both magnitude and direction, like velocity. You would say I'm going 20 miles an hour east. 20 miles an hour is the magnitude, and east, up, north, south, down is your direction. The way we denote vectors in a plane is with an arrow. One end is a point, we call that the initial point, and the other end is an actual arrow, which is we call the terminal point. The way we denote vectors in writing is either boldface or with a little half arrow on top. If we want to add vectors, if you have two vectors, vector v and vector w, then the way that we add vectors is we start vector v, and then where vector v ends is where we start vector w. Then the sum v plus w starts at the starting point of v and ends at the ending point of w. So this would be vector v plus w. Here are some properties of adding vectors. I would pause the video and write these down. So we can multiply vectors by what we call a scalar, which is a non-vector number. So if we have alpha as a scalar and v as a vector, then alpha times v has the following properties. So I would pause the video and write these down. So if alpha is positive, then the vector alpha v is the vector that's in the same direction as vector v, but alpha times longer. If alpha is negative, then the vector alpha v is the vector whose magnitude is the absolute value of alpha times longer, but is in the opposite direction of v. So for instance, if you have negative v, then it would be the same length as vector v, but just in the exact opposite direction. If either alpha equals 0 or if v is the 0 vector, then alpha times v is also the 0 vector. Here are some properties of scalar multiplication for vectors, so I would pause the video and write these down. So you can apply the distributive property, either distributing two scalars to a vector or a scalar to two vectors. Also, it's associative, so you could multiply the scalars together first and then multiply it by the vector, or multiply one of the scalars by the vector and then multiply it by the other scalar. So if we have these vectors over here on the right, and we want to add and subtract them, so we want to have v plus w. So vector v is just horizontal, it goes 5 units right, so I have vector v. And then if I want to add w, I'm going to start vector w right at the end of vector v. Vector w goes up 5 and to the right 2, so I'm going to go up 5 and to the right 2, starting right at the end of vector v. So then vector v plus w is I'm going to start at the beginning of vector v and end at the end of vector w. So then vector v plus w looks like this. So go ahead and pause the video and try v minus w. Remember, negative w is the same length but the complete opposite direction. So I started with v, I just left it in the same spot as the previous one, and at the end of v, where I finished v, I'm going to go negative w. So instead of going up 5 and to the right 2, I went down 5 and to the left 2. So then v minus w starts at the beginning of v and ends at the end of negative w. So now we want to try number 3, 3v plus u minus 2w. So you're going to do the same thing. When you do something like 3v, then you're going to go in the same direction as v, but it's going to be 3 times as long. So instead of going to the right 5, you're going to go to the right 15. So go ahead and pause the video and try number 3. So 3v, I'm going to go the right 15, 3 times as long as v, but the same direction, plus u, so when I end v, I'm going to start u, which was down 1 to the right 2. And then I'm going to subtract 2w. So I'm going to go opposite direction of w, and I'm going to go twice as long. So I'm going to go down 10 and to the left 4. So then 3v plus u minus 2w starts where 3v started and ends where 2w ends. We call the length of the vector the magnitude of the vector, and we represent it with this double barred symbol here. I would pause the video and write down these notes. The magnitude is length, so it's always going to be greater than or equal to 0, and then the magnitude of negative v is going to be the same as the magnitude of v. We call the vector that has a magnitude of 1 the unit vector. We have two notations for the algebraic representation of vectors, this pointed bracket that looks sort of like a coordinate point, and then this sum notation that says a I hat, we call this I hat, plus b j hat, where a and b are scalars, and a is the horizontal component, so how much left or right you go, and b is the vertical component, so how much up or down you went to create this vector. If we use this representation, then we call this vector the position vector, which means the initial point starts at the origin, and its terminal point is point AB. If we're given a vector where the initial point is point P1 and the terminal point is point P2, then we can find the position vector that's equivalent to this vector by the horizontal component is the difference between the x's, the two x coordinates, and the vertical component is the difference between the two y coordinates. So down here we have the vector P1, P2. So I started at initial point -1, 2 and went to the terminal point P2. So now we want to find the position vector that's equivalent to that. So when we do this, then the horizontal component is going to be the difference between the x's, so 4 minus a -1, and the vertical component is going to be the difference between the y's, so 6 minus 2. So this position vector is 5, 4, or we will call it 5 I hat plus 4 j hat. So what that means is if we want the position vector, we're going to start at the origin, and we're going to go 5 in the horizontal direction, and 4 in the vertical direction. So they're the same length vector, they have the same magnitude. We've just moved this vector now to start at the origin. So here are some properties of adding vectors and algebraic vectors. So if you're given two vectors v and w and a scalar alpha, then these properties hold true. I would pause the video and write these down. So if you're adding two vectors, then you just add the individual components. So you would add the horizontal components and add the vertical components. Same if you're subtracting. If you multiply a vector by a scalar, then you just multiply each component by the scalar. So we did in the very beginning, we did 3v. So the horizontal component was 5. Well, 3v, the horizontal component was 15. It was 3 times that. The magnitude of a vector, because it's just the length of the vector, is Pythagorean Theorem, square root of a squared plus b squared. So using those properties on the previous slide and the given vectors v and w, go ahead and pause the video and find 3v. So we're just going to multiply the vector 2, 3 by 3. So instead of going 2 in the horizontal direction and 3 in the vertical direction, we're going to go 3 times that. So you're going to get 6 in the horizontal direction and 9 in the vertical direction. You can either leave it in this bracket notation or you can change it to 6 I hat plus 9 j hat. So go ahead and pause the video and find 2v minus 3w and also the magnitude of v. So if we want 2v minus 3w and we start with vectors v and w, then we multiply v by type 2, we multiply 3 by w, and then subtract the 2 just by subtracting each set of components. So the resultant vector is -5 in the horizontal direction and 18 in the vertical direction. So -5 I hat plus 18 j hat. Magnitude is just Pythagorean Theorem, square root of 2 squared plus 3 squared. So the length of vector v is the square root of 13. So the last part is finding unit vectors. So if for any vector v, we can find the unit vector, which is a magnitude of 1, that has the same direction as vector v. The way that we do that is unit vector u is equal to vector v divided by the magnitude of v. So we want to find the unit vector that has the same direction as v, which is equal to 4 I hat minus 3 j hat. So first thing we need is we need the magnitude of v. So go ahead and pause the video and find the magnitude of v. So this ends up being a 3, 4, 5 right triangle. 4 squared plus -3 squared is 25, so square root of that is 5. So now if we want to find the unit vector, we're just going to divide vector v by that magnitude of 5. So we end up with 4 I hat minus 3 j hat over 5, which you can rewrite as 4/5 I hat minus 3/5 j hat. So this vector is in the same direction as the original vector v, but it has a magnitude or a length of 1.